The Tsunami Research and Tsunami Early Warning in Europe. And I think Professor Stefano Tinti will introduce all the panel members. There's one without a name badge, and that's Dr. Papadopoulos. He came in here later. Stefano.
Okay, thank you very much. May I use the microphone? So I thank you very much, EGU, for giving us this chance to be here with the press conference on this topic that for us is very important. And we did that even in some of the previous years. I don't know, probably not regularly over the years. The idea, of course, is to give you an idea what is the status of the tsunami research here in Europe, and more importantly, probably, what is the state of the art of the tsunami early warning and implementation in our area. We are perfectly aware that the interest on tsunamis in these days is much increased after the tsunami in Japan, the Tohoku event, and the tsunami in Japan. We know that, and we invite you to, if you like, to ask questions also on this topic, but you should be aware and informed that tomorrow there will be a special event on the Tohoku, a session, a special scientific session, that is composed by oral presentation and then of poster presentations. And but it's even more important, you know, for you that there will be a panel in the afternoon, and you are also allowed there to ask questions to the panelists. So there are specialists in there. But even here, because we know that anyhow you have this interest even today here, we have two of the major experts that are here in Europe in these days. Fortunately for us, they are not in Japan. They wanted to take part in this assembly, EGU assembly here, and they know very much that, of what happened in Japan. So you can ask them about earthquake and about tsunami. One, just to start from my left, is Professor Kato. He is from Earthquake Research Institute of Tokyo in Japan. They have a booth here. He will be also one of the panelists tomorrow and one of the speakers in tomorrow morning. So he will give us a lot of information on earthquake and especially earthquake and the damage of the earthquake, etc. And on the other side, just to cover the other aspects, on my right, there is Professor Dr. Yamamoto, and he's very important for us. He is senior advisor now in Europe. He's working in Paris at UNESCO, IOC. IOC is the Intergovernmental Oceanographic Commission, but more important, he was director, he is past director of JMA. JMA is just the agency in Japan that takes care of the tsunami alert system. So he knows perfectly well how it works and how it performed, because he was just in these days looking at the performance of the system. And then, in addition to that, just because it's important for us to speak here in Vienna at the EGU of tsunamis in Europe, we have collected here the major expert of tsunamis and tsunami early warning in Europe in this table here. And just to start from the left, that is Dr. Gerasimos Papadopoulos, who has a double responsibility. He works within NOAA. NOAA is the National Observatory of Athens. That is the institute that is responsible for the implementation of the tsunami early warning in Greece. And then we will say other things about that. And is also within the acronym is this very different, very complicated acronym that you see here. Anytime I have to explain what it is. So this ICG-NINTWS is the Intergovernmental Coordination Group for the implementation of the Northeast Atlantic and Mediterranean tsunami warning system. So each letter has a meaning because it's an acronym, but it's very complicated to tell. So it's an organ, that body that has been created 4 years ago to implement a system that it's not there. It's not yet there. So that's the body is there, the system is not there. So we can accept all kind of question and criticism. And he now is the chair of one of the sub-body of this group that is called the Task Team for the System Architecture. Then here is my friend Jorn Lauterjung that has more happier than us because at least he concluded. So he was effective in implementing something. He is responsible of the implementation of GTEVs. GTEVs has been advertised very much in these days. It's still an acronym. It's German-Indonesian tsunami warning system. And of course, it's something that has been implemented in Indonesia, and you can ask everything to him, and he will present himself later. And then we've got here also Dr. Joachim Wächter, both of them, so Jorn and Joachim, comes from the same institute, the GFZ in Potsdam, Germany, and he coordinator of a EU project, so a project that is financed by the European Union, one of the few now on tsunamis. That's to be remarked that the European Union did finance very few projects on tsunamis. I happened to be one of the coordinators of a project that is finished already. And now probably there is only this project that has to do, is not exactly on tsunami, but at least has to do with tsunamis. And he will explain to you what kind of project it is. It's called TRIDEC. It's another acronym, but I don't want to explain you all the secrets of this acronym. They are there here and then can tell you. So this is our table here. Now the mechanism is that each one of these speakers will give you a very short presentation of himself, much shorter than me. I've had the advantage of being the chair, so I exploited this, but they should be very, very strict because the most important thing is for you to ask questions. So we are here. The time is up to 1:30, but indeed, unfortunately, at 1:30, most of us are also engaged in another block, so in another session, the scientific session on tsunamis. So today is all devoted to tsunamis. And so me, Jorn, and Joachim had to rush, in a sense, and run again to room 4 where our session is. So probably some of us will leave you 5 minutes before in order to be there on time, but this is the idea. So now I switched, and here I leave my place here. And so Gerasimos can come. I stay there. Of course, I'm also able to. I'm involved in tsunamis for a very long time. Let me say 30 years. I don't want to add anything more, so you cannot guess my age. But I go there, and so I'm ready to answer your question. Thank you very much. So I go just here. If you are interested, this is the map of the tsunamis in the Mediterranean. And so you can see that almost all the coast of the Mediterranean are affected by tsunamis, either because they are near shore, near the sources, or because tsunamis generated there can travel through the Mediterranean, cross the Mediterranean, and affect the other coast. So I spent a bit of time in making you wait for me just to show this, and I almost forgot to show you that this is the map of the tsunamis in the Mediterranean that have been prepared as a result, in a sense, one of the many results of the project that I coordinated, and one of the few projects that were financed by the European Union. Thank you very much.
Okay, thanks to Stefano for this introduction. I will be very brief regarding the question if tsunamis are there in the Mediterranean and the Northeast Atlantic, because most of the people say, oh, there is no tsunami hazard in our area, or others say, oh, it's a very closed sea and it's not a possibility, geophysical possibility for having tsunami. So I will show you only very few slides. Don't be afraid, I'm not going to take a lot of time for this. This is the main seismotectonic structures in the area. We have very high seismicity. Most of the earthquakes takes place in submarine environment. Some of them are very large in magnitude, and because of this, it would be a geophysical paradox for not having tsunamis from very large earthquakes in the submarine environment. It would be not possible to be an exception on what happens in a global scale. So we do have some tsunamis. And this is another version of what Stefano just showed before, is a generalization of the main tsunamigenic zones that we have been able to draw all along the Mediterranean Sea from a record of tsunamis starting from historical times up to the present. And one may see that we have several tsunami sources which threaten coastal zones of the Mediterranean Sea. And there are several examples: the 1856 in Algeria, the 365 AD very big earthquake and tsunami in Crete Island and in the Eastern Mediterranean in general. In all places of the Mediterranean we have many tsunamis, but I would like just to show you the most recent example. It was in 9 of July 1956 in the South Aegean. A very large earthquake measuring magnitude 7.5 in a Richter scale produced extensive destruction in the islands around the epicenter, but at the same time it was a very big tsunami. You may have some opportunity to take a look in some very rare pictures. They are stored only in the archive of the National Observatory of Athens, taken by the scientists of my institute. At that time, they were pioneering in tsunami hazard research at that time. You see here in one of the islands, Kalymnos Island, close to famous Mykonos Island. The first picture shows how the tsunami has withdrawn and then inundating, few minutes later, inundating the coastal zone of this island. Then in this island, excuse me, the wording is in Greek by a recent presentation that I gave in these islands, but never mind, is again Kalymnos, and you may see some similarities of what we have seen recently in Japan or a few years ago in Indonesia, very big fishing boats that were moved ashore because of the strength of the tsunami penetration inland. And in another island, in Leros Island, again same thing, withdrawal of the seawater and then inundation, and similar in Patmos Island, and so on and so on. This is the only that I wanted to tell you as very few examples and general introduction. Yes, there are tsunami events in our area. Maybe they are infrequent events, but infrequency does not mean that we are safe. This is the lesson, not from Japan, because they are frequent, but the lesson from the Sumatra 2004. Quite infrequent, but we are not safe. Thank you very much.
Thank you, Gerasimos. And if you have other slides, etc., maybe you can show them if somebody asks you something that you can cover with your slides. But I ask and I invite everybody to be very concise. So let me first go through the European in a sense, and then I will leave the two Japanese researchers and colleagues here as the last one. So please, Jorn.
Yeah, okay. I have only 2 slides, so no, it's okay. This one? Yes. Okay, just to give you some information on the state of the art of tsunami early warning. Gerasimos already told you on the risk in Europe and the possibilities of tsunamis. So our activity started December 26 on the Boxing Day with the Indian Ocean tsunami, where it was very soon very clear that many fatalities had been because there was really no warning structure, no information structure at that time. And we immediately started to offer some help for the Indian Ocean countries and started in March 2005 in Indonesia. About 2 years later, they have been able to issue their first warnings after an earthquake nearby Bengkulu in Sumatra. In 2008, the official start of the operational phase was done with a warning center at BMKG in Indonesia. And since about 1 week, the system is under the responsibility of Indonesia, has been handed over. We will accompany the Indonesian colleagues for a couple of years, improving operation and maintenance things. But After 6 years of work, or 5.5 years of work, we have an operational tsunami early warning system for the Indian Ocean. The main elements of this project are, it is thought as an end-to-end system, so we have instrumentation to characterize earthquakes, looking at deformation, looking at sea level changes. Very important part is a modeling and simulation part. All this information comes into what we call a decision support system to help the people to decide whether warning shall be issued or not. Even also risk modeling, risk maps have been produced for the complete coastlines of Indonesia. And last but not least, the main important part of the project was capacity development and public education for the people. So what I wanted to say is that the geographic situation in Indonesia and also in Europe, you have seen the maps from Geosciences, are quite comparable. So we are dealing with near-field tsunami threat, as we say, so it's only very short tsunami travel times, and that needs a special strategy and technique for early warning, which has to be done in the very few minutes, 4 minutes after the earthquake. And showing with the example in the Indian Ocean, we have the experience and also the advanced tools available in Europe for doing this tsunami early warning. And as Stefano said before, structures are available. We have discussed since many, many times, but now, and that may be a little bit provocative, but now political decisions are needed so that we really can start implementation and putting things into operation. Thank you.
Thank you very much, Joran. And now I'm asking Joachim to say a few words about the project and the purpose of it.
Das hier, ne?
Okay, before
Would you like
I...
to come over here?
Ich kann
No,
das.
okay. Our role...
Use the microphone.
Okay, I'll use the microphone. Is it okay for you? Okay, our role in the overall context is harnessing information technology for the development of early warning system. And the information and communication technology plays a very important role in this overall context. There was a call of the European Commission at the end of 2009. It was the context of intelligent information management, and we were successful, and now we have a TRIDEC project, I will give you some details later on, that will use information technology and techniques of intelligent information management for the tsunami early warning context. Well, our overall objective is that we want to build a new generation of early warning systems that uses new technology and new architecture, and these systems will be based on standards. That means that it's open, extensible, and so on. And important requirements for this kind of system, it must be somehow small, not a monolithic system, it must be cheap, it must be adaptive, and very important, it must be self-learning. We have rare events for tsunamis, and therefore a tsunami early warning system has to be trained to be successful because the tsunami events are so rare. And last but not least, it's very important that the overall system is open for future innovation. The Mediterranean region is interesting for this field of information technology because there is a reduced time for early warning. It is a multilingual environment, and we have a very complex political situation, and this has to be reflected in the architecture of the information system as well. Very important is that the developments are open for new development. For example, mobile technology, smartphones and sensors linked to smartphone will be a very important field for tsunami observation in the future. And cloud computing approaches for utilization of services and so on will become very important as well. But it has to be mentioned quite clearly, and that has to be mentioned from other here as well, that this is early warning is no simple IT business. It has to be embedded in political activities. The policies must be right to access to that, to sensor systems and so on. We have to have training and education so that we can disseminate the system. And if these kind of components of the systems have to be disseminated in a broad community, it's necessary to have somehow a politically correct license model. The next slide, please. Okay, and this is an impression of the EU project. It has 10 members from 10 European countries. We have 3 partners from the application field. That is the Candili Observatory, the Instituto Meteorologica of Portugal, and the University of Bologna, and several other groups that are in the core field of technology development. For example, one company, it is Qsphere, is coming from the field of stock exchange, where time series are interpreted to select and detect events. Thank you very much.
Thank you, Joachim. And now I invite Professor Kato to say a few words of introduction.
Can I use the
Yeah.
file?
Just in there.
Yeah.
Please come here.
Okay. Yeah. Okay, I'm Terry Kato, came from Japan. I'm working at the Earthquake Research Institute, and I just want to give you some information about the earthquake, what happened so far. And, oops, okay. As you know, the earthquake was magnitude 9, and it devastated the half part of Japan so far. So it was really a bad earthquake for the Japanese people. Okay, this is my presentation slides for the tomorrow, so you can find a little more in detail. First of all, I should say that Japanese islands are surrounded by a number of plates. The so-called Pacific plates and Philippine Sea plates are subducting beneath the Japanese island, and that creates a very large interplate earthquake and of the size magnitude 7 or 8, and that creates a large tsunami. So in historical ages, Japanese people have suffered from these earthquakes and tsunamis. Now, the earthquake of March 11 occurred here. Now, even if you think about the, say, magnitude 8 earthquake, the size should be something like 100 by 100 kilometers of hypocentral region. However, in this time of earthquake, the hypocentral region was something like 500 kilometers by 200 kilometers. So it's much, much bigger than what we have experienced so far for magnitude 8. And it became magnitude 9 earthquake. So the main main shock occurred at that orange colored part, but the largest aftershock occurred in the southern end of this hypocentral area, and that was reached to magnitude nearly 8. So even aftershock was very large. And this whole area generated tsunami. And this is just the cluster deformation and observed by using GPS. And this shows that nearly more than 5 meters of the surface moved towards southeast. And we are investigating from this cluster deformation data how big was the slip of the source area. And it attained nearly 20 meters. Someone tells that the other modeling suggests that it might be more than 20 meters, maybe 30 meters of offset occurred along the surface, along the fault. Now, this is just a comparison between cluster deformation modeling and seismological modeling. Now, another aspect is tsunami. And there are a number of techniques that we observe tsunamis. There are mainly 3 kinds of techniques are used for not just for observation, but also tsunami early warning system. The first one is tidal gauge records, but it is located along the coast, so it's not so useful to give the information of tsunami before its arrival to the coast. So we are using also the ocean bottom pressure sensor, which is located, say, 50 kilometers or 70 kilometers from the coast. And also we are using GPS buoy. The picture is shown here. All of these are used for giving the early tsunami warning in Japan. But still, it was a little bit too late for people to evacuate from tsunamis. The field surveys is now undertaking, and they say that so far about 40 meters of run-up height was found along the coast. So this is still very preliminary. So later on you could find out much higher tsunami. But this is just a very preliminary thing. So the Tsunamis researchers are now trying very hard to find how large was the slip on the fault, and using these things. For example, ocean bottom pressure sensor showed about 5 meters of the uplift of the seafloor. That created tsunamis. And if the tsunami goes to the coast, that is exaggerated as the ocean, the depth is shallower and shallower. So that created the tsunami more than 10 meters height along the coast. Okay, and the modeling suggests that the maximum slip of the fault is more than 30 meters, maybe 36 meters of offset along the fault. And these are all preliminary results, but these could tell you how large was the earthquake and tsunami. Right.
Thank you very much, Professor Kato. So, and now the last speaker, Dr. Yamamoto from JMA, past director of JMA.
Not a JMA, no more JMA.
Yeah, no more.
So I'm working at the member states of the IOC. The IOC means the Intergovernmental Oceanographic Commission. And my main responsibility is to support how to establish a national tsunami warning system, or regional system, and the ocean-wide system. And this just brief explanation here, how the JMA respond to this earthquake. They issue the tsunami warning within 3 minutes. And after that, they continue to monitor and evaluate the magnitude of the tsunami and the magnitude of the earthquake. Based on the evaluate data, they continuously upgrading the tsunami warning. Finally, they issue the tsunami warning, or major tsunami warning, or tsunami advisory for all coastal area in Japan. I don't remember such a case. So this is, I think, this is the first time. In case of the JMA started the tsunami warning service in 1952. Then they are, at the beginning, they could issue the tsunami warning around 20 minutes. Now they can issue the tsunami warning within 3 minutes. So it's based on the lot of experience, the division of the system, and improving the system, and improving the so-called standard operation procedure. Then they could reach this level. I think this is one of the most advanced systems in the world.
Okay, thank you very much. So now it's your turn. You can ask us everything you like.
Yes, who would like to?
Thanks. Sure. Yeah, Richard Black from the BBC. I actually had 2 questions. I don't know if I'm allowed to ask 2, Dick, am I? I wanted to ask Professor Kato, having seen this magnitude 9 quake in this Tohoku region, how is that altering understanding among Japanese academics of the potential of this zone, and indeed the sort of shape of this zone? And I also wanted to ask Dr. Vector, the system that you're in charge of, why, can you just outline why perhaps it isn't in operation yet?
From me? Oh, okay. Okay. Your question is very difficult to to answer, actually. But anyway, you are right that we have to think about what we have to expect in the future. What type big earthquake should be expected in the coming years. And one thing is that this kind of super large earthquake can occur at any area where long subduction zone exists. And we already have some examples in Chile in 1960, in 1964 in Alaska, and 2004 in Indonesia and Andaman. And the same thing happened in Japan. That's all what happened. However, one more thing is that we have another coastline in the western part of Japan. And that is another place that we expect a super large earthquake nearly magnitude 9. So in the northeastern part of Japan, we did not expect that large of earthquake of magnitude 9. Maybe it was wrong. So we may have to re-evaluate all of historical earthquakes, and we should evaluate of magnitude 9 class earthquake in the future. I'm not sure of the result, but we have to do that in the future.
I may add something to this because I'm not an expert of Japan and tectonics, but it's certainly true that the 2004 case and now the 2011 case showed us that probably we did not so far, seismologists and tectonic people did not so far make the right estimate of the maximum possible expected earthquakes. And so this is very important for a number of consequences. One for all is about the tsunami. So tsunami hazard and tsunami risk, because of course a larger earthquake can produce larger tsunamis. Probably is less important as regards the seismic waves, because there is a sort of a saturation of the seismic waves. So probably the damage that is caused by an earthquake of magnitude 9 or an earthquake of magnitude 8.5 more or less is the same, because the acceleration are the same, etc., etc. It's a simple question of having a larger area. So of course it affects a larger area, but not with a larger power. So the power is this. But for a tsunami is different. So that's important to understand this point. And probably this can apply also to other areas. Not the fact that we can have in Europe, for instance, magnitude 9. We are not expecting that, but probably the maximum earthquake that have been established in a sense, and we expect in a different faults could be revised. So that's important to know. So now, Joachim.
Thank you very much. Well, the answer why this system is not operational now, our project started 6 months ago, and that is a very simple answer for this question. But on the other hand, you have to see the Mediterranean area that is very complicated if you look at the political framing conditions, and what we are intending in our TRIDEC project, that we take all development from other projects, for example, from the German-Indonesian tsunami early warning system and from other EU-funded projects, and the knowledge from other communities that are prominent expert in the field of intelligent information management, and bring it into the concept of a new generation of early warning systems for the Mediterranean. But there's another step that has to be identified quite clearly. There are, on one hand, technological solutions, but in parallel, there must be some political processes bringing things forward, and there must be something as policies for a Mediterranean early warning system, for example, giving access to data and so on. And that is very important. That has to be looked at in the future. So it's not simply a technological problem. If it would be only technology, we would have already had the solution, but it's a combined problem, a political problem and a technological problem.
Thank you, Joachim.
Sure. Randy Shostak, reporter with EOS, newspaper of the American Geophysical Union. I wanted to follow up on that thread because, Dr. Wachter, you weren't the only person who mentioned the political needs. Dr. Lautenjung also mentioned that. And so I wonder, when we're faced with such disasters and such potential disasters, whether you could expand a little bit more about what is needed to get the political will there to put these systems in place, and why that political will isn't there. And I'd like to hear from Dr. Yamamoto also, and from perhaps some others, to see, for instance, whether the political will is there from the member states of the IOC.
Okay, please. No, I can start and tell that after the 2004 tsunami, within IOC, so did UNESCO, IOC, etc., they decided to set up not only the Indian Ocean Tsunami Early Warning System, so to create a special group of that, but even two more groups, one for the Caribbean and one for Europe. And I happened to be for the first 4 years of this, from 2005 to 2009, the chair of this group for Europe. And that was the main problem, political problem, because from the technical point of view, of course, there are challenges, but the basic was already there. And putting together all these member states in order to have them cooperating together and putting money that, after all, was very little money compared to the power of a state, was a very difficult task. And indeed, there has been no money put apart a few million euros that have been put by France. So no other countries put some money in this operation. And so maybe at least in the first 3 years or 4 years. And so only recently, starting from 2009, 2010, some efforts have been put by these countries that are the developed countries in Europe. I'm not talking about the southern Mediterranean countries, so Libya, Tunisia, Algeria. I'm talking about Italy, France, Spain, Portugal, Germany, etc. So there was, there was interest just after the 2004 case, and then the interest very rapidly decreased. That was my experience. Please.
No, I can nothing, or only small things to add. First, you always have to think of the fact that warnings are national processes. So a nation has to discuss or has to decide that for civil protection things, tsunami early warning at their coastlines is important. And then, as Stefano already said, what we need to implement finally the system from a basis which is very good in Europe concerning instruments, concerning knowledge, concerning technology, all these things, is simply what has already been said before, that we need policies to exchange data, to make data available as quick as possible, and that we have the support of the different nations to finance, to do this last step, if you like, to implement this exchange of information, to implement, let me say, unified warning structures, so-called standard operation procedures, something like this, and then to start off with this. And the next problem, Stefano already told you, is the integration of the North African countries, because tsunami early warning, only looking from the northern part of the Mediterranean, is only half of the game. So we also need some implementations there. One hope is there is a EU activity called the Union for the Mediterranean. That is a follow-up of the Barcelona process some years ago. They have now established some structures with the presidency and the bureau. And the hope is that in the next years, through this instrument of the European Union, we can implement some Mediterranean-wide early warning system. But this is unfortunately still future. A lot of discussion still has to be done.
It's a hope.
It's a hope, yeah.
Stefano, may I add something? Okay, if you
Can you just after?
Okay.
I think one of the very big achievements of the political issue is the CNTV.at provide the real-time seismic data to the National Tsunami Warning Center recognized by the UNESCO. That is a very big progress.
Okay, thank you.
From my point of view, it's very important to realize that we have the political will on one hand, but on the other hand side, we have to have money for the establishment of such type of systems, because integrated approaches, they need integrated money and a lot of money. And therefore, we are very glad that we have on the European level the TRIDEC project that at least for the coming 2.5 years can promote this process.
May I add something, please, on the so-called political issue? Political is coming out from the nations, but also from the European Union. the funding that has been given so far by the European Union is zero for the European tsunami warning system. There is a lot of money, maybe not a lot, but some substantial money given for basic research, like the transfer project that mentioned before by Stefano. Several of us participated, including my team. But for the early warning system itself, the only money that has been given, after, of course, open competition for proposals, were given for the German-Indonesian project. And again, I would like to emphasize that the German government had a very great interest, and it's a very positive paradigm to invest for the Indonesian tsunami warning system. Looking in the picture, no other money has been given, very little money from this or that government or some, let's say, marginal funds projects of the European Union to increase our infrastructure. Practically speaking, according to my understanding, there is a lack of European Union policy for early warning system of tsunamis. On the other hand, there is a very well coordinated policy coming out from UNESCO, the Intergovernmental Oceanographic Commission, which of course has no money to distribute, but is a very good, let's say, table to sit all the nation members down and discuss the political issues. What is the political issues? If we want to disseminate warning for Alexandria, for Egypt, for a tsunami which has been generated in Greece going down, or from Italy to Libya and so on, it's not so simple to say, oh, you people in Egypt, take this message from us. No. There is need for protocols. Behind these protocols to be signed is the political will from both sides, and you may understand all the possible combinations. This is another dimension of the political issue. So, according to my opinion, we are not so much late in Europe in establishing the tsunami warning system. In Indonesia, it was a single country that was very badly hit by the Sumatra 2004 very big wave, and also a very decisive government and institute, the GFZ from Germany, to go there and to do the job. So you may have some other dimension of the picture and of the problem. But I am also optimist that concluding with this, the coordination, the effective coordination of IOC UNESCO by the end of this year, or the latest within 2012, at least some of the regional centers for NEAMS will be there in place, becoming operational.
Who else?
Sorry, just a bit of a point of clarification. There were a lot of acronyms banded around. And I think for Europe, we have 3 acronyms, if I'm right here. I may have missed something. I wonder if you could just run through the different European programs here. Just to clarify things for us.
No. So you are asking the composition of this table here?
No. Well, I mean, I'm asking. Well, we have the one project that Dr. Wachter is involved in, but he said that's only been going for 6 months, and then
not for 6 months.
is talking about another project which goes back several years, and that had a different acronym. You had a different acronym as well when you were introduced. Just clarify that.
I can be more specific. So about the European Union policy, if you like, in funding the research project on tsunamis. So the first project of tsunamis that was financed by the European Union was in the 90s, and it was called GTEC. And second, there was another project that was called GTEC2. All of these projects are 2-3-year projects. These were very little projects that were financed at that time with it was, sorry?
Could you spell those acronyms?
C is GITEC, GTEC. And means I was the coordinator. I don't even remember what was the meaning of the acronym. It's
Genesis and
Genesis and the impact of tsunamis on the European coast. That was the acronym that was found. And it was the first community of people that were collected in a sense around Europe and were interested in tsunamis. You consider it was 90s, so 91, 93 the first, 93, 96 the second, and at that time speaking of tsunamis at the research level or speaking of tsunamis with some authorities was just speaking of some very strange thing. Nobody didn't understand what we were talking about, what was the interest, etc. Then there remained a whole of 7 years. And when the European Union found itself with this 2004 case, found itself completely uncovered on the topic. They were surprised. And they, at the end of it was the last year, you know that European Union is organizing in FP now we are in FP7, so it's this framework program. We are in FP7. It was at that time FP6, and they were at the last year of the FP6 life, and they decided to finance with some residual money that they had there. They financed 2 more projects. One was called Transfer, and the other was called Nearest. And I can tell you that the total money was 5 million. So this was given. And this was for research. And we collected many more people and many more institutes, 29 institutes from more or less all Europe around these 2 projects. And with FP7, other projects have been financed. So in total, there are 5 or 6 projects. I've got in some of my presentation the table. If you are interested, not now, maybe later I can give you the table of these projects that have been financed. There are less than 10 projects that have been financed so far in different programs of the FP6, but they started more or less in 2005, 2006 with the duration of 3 or 4 years. And then now, they didn't find any more money within FP7 for financing and for continuing financing research on tsunamis, apart from TRIDEC. So that is the reason I tell you that this is the only project that is financed specifically devoted to tsunami early warning, but not on operational, not on the operational side, but just to devise the technical and in the communication, the platform, the technical platform to set up in order to be distributed and to be implemented and applied in the countries that can have the tsunami problem. So as a total, I can tell you that summing up roughly, in these 5 years, something around 8 million probably have been devoted to tsunamis. That is nothing. And consider that only Germany spent something around 50 million or 55 million, invested this money in Indonesia. So this is a nation that decided to spend its money in Indonesia, and it gained a lot of experience that is also important for us. But it has been spent in Indonesia for a specific problem on national funds and not on the European funds. So the total is much less. And I don't know what is the estimate to implement a tsunami early warning system in Europe, but probably the estimate is around 100 million. And 100 million is nothing for the European Union. This is the problem. So this just to give you an idea of the size, of the figure, of the scale of what we are talking about.
Holger Kroker, if I get it right, a very large part of this tsunami early warning system falls into the boundaries of national states. So what about the national states in the Mediterranean, like Greece, like Italy? What about bathymetry? What about all these risk models which have to be applied as a part of early warning systems?
Gerassimo, what would you like?
Okay, very briefly to say that, thank you, Stefano, that as Stefano said before, the European Union in the field of research is not a newcomer in tsunami research, since understood very well the problem and funded GTEC and GTEC2 since 90s. This gave us the opportunity to say that we don't start from zero. There is a very good research background, data compilations, databases, and so on. And this is a privilege, this is an advantage of all the country members and institutions that would like to contribute in the tsunami early warning system, because you are correct, all these things make a necessary infrastructure for implementing in practice the early warning system. Of course, we need better bathymetry. Of course, we need better digital elevation models for the coastal zone, because we have to also give some hydrodynamic parameters describing the inundation of the tsunami when it arrives in the coastal zone, and so on. But there are also hazard, vulnerability, and risk assessment and mapping technologies that started to develop for our region since the 90s as well, maybe earlier, some of them. So we are in very good position from this point of view.
I can add something regarding Italy. So for Italy, there has been a project that has been financed by Civil Protection in the last few years that is called MAGIC. And this is just a project whose coordinator happened to be here, not in this panel here, but it's in this EGU. It's called Francesco Chiocci from the University of Rome. And the purpose of this is to have a very detailed bathymetry of disease around Italy. Just for this purpose, even for tsunami in a sense, because they want to know there are instabilities, and they found a lot of instabilities in the margins or landslides that they didn't know they were. They suspected, of course, but they didn't. So it's a very huge effort with the involvement of the largest institutions in Italy, and so this is a national project. This is a national, and there are many others national projects. Please.
So the most important part is we have to establish a so-called end-to-end system. It means how quickly the warning should issued. And another end is how quickly disseminate warning to the public and how quickly evacuate the people who are staying in the tsunami threat area. So we have to have a so-called total system, not only to issue warning as early as possible.
Well, thank you, Dr. Yamamoto, and all of you. I think we'd rather stop now because they have to leave in a minute, and maybe some of you want to make an interview appointment with them. Is that okay? Okay, then thank you very much for this very clear presentation.
Thank you very much.